AI next generation channel. In this particular video, we will look at through how to train our ANN model, how to train our CNN model. So in the previous video we already have seen how to create the RNN layer, how to create the CNN model, how to create the ANN model. Okay, you have gone through these three particular model how to create, and each and every step I have explained in the more details. You can even watch, if you have not watched that particular video, how to create the model, you can just go, I will just give the link in the description. You can just directly go to the playlist of this particular PyTorch. You can just directly see all the video related to the PyTorch. Okay, so in this particular, our main focus is to build our training function so that it can train the both CNN model and it can train the both ANN model. Okay, so because you are just creating the model is only the difference, but the training function for the both ANN and CNN will be the same. Okay, so what you are going to write before creating the training function, what you have to just say what loss function you are going to use, what optimizer you are going to use. Okay, so you can just initialize this thing. Okay, you can just write loss function and you have to just write here, and you are just writing from nn dot cross entropy loss. This is the loss function we are going to use in this particular model for the both CNN and ANN. Then after, you are going to create the optimizer for that. Okay, optimizer, you have to write, already we have just imported this optim. From optim you have to use stochastic gradient descent SGD, and then after you have to pass the model dot parameter. Okay, parameter you have to pass, and then after the second thing it will take the learning rate. Okay, so learning rate you have to keep 001. Okay, so you have just initialized the loss function, you have initialized the optimizer. Now you have to create a function. Okay, you have to create the training function. Okay, so in that you are just passing the model, that can be ANN or that can be CNN model. Okay, and then after you are just passing the loss function for that. Then after that you are passing optimizer. Okay, and then after you are passing the number of epoch you want to take. Okay, so this thing, it is clear for you. So it's like really you are just taking these sorts of parameter. Okay, so now what you are just doing, you are just iterating through all the epoch. So you have total 10 epoch you are just taking, you have just taking. So what you have to do, it will just loop through the 10 times. Okay, so 10 epochs means 10 times the forward propagation and the back propagation the model will do. Okay, so during the training phase. So what you are just writing here, so it's really easy. And then after that, before doing this one, we have to also visualize this particular model. Okay, so if you want to visualize the curve between a training or testing, how they are just increasing on the accuracy, and based on the loss how they are just decreasing, where your model is overfitting or underfitting. Means overfitting means your training accuracy is really high, but if whenever you're going for the testing accuracy, it's really low. So at that time you can say your model is overfitting. And if the both the training accuracy and the testing accuracy is going down, so you can just say that particular model is the underfitting model. Okay, so for visualizing, you can just do the visualizing with the help of matplotlib. For that you have to create a list. Okay, you can just write training accuracy, you can just write training accuracy, training, yeah, you are just creating an empty list for that. All the, if after every epoch you will see the what is the training accuracy, and you will append in this list. Okay, similar, you can just write the training loss, and you're creating the list. And then after testing accuracy, you are just creating the list, and testing loss. Okay, testing loss, and you're just creating the list. Okay, so I don't think so you have doubt in this. And then after, you're just iterating through all the epochs. So for that, okay, so for that again you have to just write here training loss. Now don't write training loss, because it will overwrite what you have created the empty list. Why I'm just writing train loss, so you can just, you want to see after every epoch you want to print that particular train loss and train accuracy. So you will see how your model is increasing the accuracy and decreasing the loss. Okay, so for that you are just initializing from the float value, and then again you are just going for the training accuracy, and you are just initializing from the 0.0. Okay, now it's clear. Now you are just saying to the model, this is in the training phase. Just why you are writing model.train means you are just in the training phase. That's it. Okay, now what you are going to use, you are just iterating this particular images comma labels in train loader. Okay, so you are just iterating this thing. What does it means? So what does it mean means you already have the, in one batch you have divided every everything into batches. You have 64 images in one batch. Okay, so you have 60, you have, how many batches you have divided can have 64. So you are just taking the first 64 image, you have the images of that and you have the label of that, and you want to see, and whenever you are just feeding that image to the model, so what model has been predicted and what actually for that particular 64 image, then you are going to back propagation, and then after you are just updating the weight. So you are just doing everything into batches form. Okay, and you are using that for optimizer, you are using as a stochastic gradient descent. Okay, clear for you? So what you are going, what you can just write here, optimizer. First of all, what you have to say, optimizer the zero grade. What does it mean? So whenever you are just setting zero grade, means you are just resetting the gradient, so that the first iteration, whenever you are getting some gradient, so it can, whenever you are doing the second time looping this thing, so it will, what was the previous gradient, it will just take as the input for that. But for now what you are doing, every iteration you will have the, every batches of image you will have the different gradient, so that it can able to update the weights. It is not dependent on the previous. That's why you are just going, you are resetting this, resetting, or reset, you can just write reset the gradient. Okay, so I don't think so you have doubt in this. Then after that you will just pass the, you will get some output, you will pass the images to the model. Okay, so you can just directly write the here, you will just pass the model. You are not writing model dot forward, because this is the, this is the basically the forward method. It is basically used for the forward propagation, this method. But whenever you are just writing model and then after you're just passing the image, so by default image, PyTorch will figure out that you are using the forward method. Okay, so no need to call model dot forwards. Okay, even you can just call model dot forward, it may run. Okay, but the thing we are going this thing, because in the backend there is callbacks and something they are just implementing by default, so you don't have to go that much deep. You just take that particular model, what you have, just make the object of that and just pass the images. Okay, so yeah, this was the basically, and then after you will get some output. Then after you will just see the loss. What is the loss? You already have the loss function. Okay, then in that particle, what is the output, what the model has been predicted, and what actual your label has. Okay, so you will see in the, in basically you are going to use the cross entropy loss. So cross entropy loss, by default they will use the softmax activation function. First they will convert everything to probability form. Then after it which particular out of 10 neurons, you have 10 neurons in the output layer, and which neuron will have the highest value, highest probability, that particular model has been predicted, and then after it will match with the actual one. Okay, whether you have, then after what, if you have the higher loss, then it will go to back propagation, it will just update the weights. Okay, the way it is going to go, that's okay, how you are just going for that. Then for that, how you are just calculating gradient, so with the help of loss dot backward. Okay, so whenever you are just writing the loss dot backward, you are going to calculate the gradient. That's it. Okay, it's calculate the gradient. Okay, so they are really easy. Then you have just passed. Then after you have to use, you have to just apply for all these particular optimizer. Okay, so optimizer step means you are just updating the weights for every. Okay, so every you are just updating the weights. Okay, updates the weights. Okay, so you have the update the weights. What you are going to write here, you have the loss, you have the you have done the back propagation, that is you have just calculate the gradient, and you already have the optimizer dot step means you have just update the weights for every features or what the weight you have in the previous one. Okay, so that thing that was really easy. Okay, now you want to see the loss. Okay, you want to see the train loss. So how you are going to see the train loss, you are just, you doing plus this, after every iteration you are just adding this thing into train loss. Okay, for that you are just getting loss dot item. Okay, so from loss you are want only item, it basically means you are getting some loss from here. Okay, now you are just adding to what was the loss we have in this slide with 0.0, so it will add up in this again. In the second iteration will go, it will add, so it will add for the of the only one epoch, so that after completion of one epoch means this is the iteration is going now. How many iteration it will go depends upon, you have the data set, you have 60,000 images, and you have, and each and then you are dividing them into batches, means the first 64 image it will go, so 64 image it will take, and it will iterate up to, so you can just divide 60,000 divided by 64, that many iteration it will go do this particular. Okay, and you will get the loss of that. So you are getting the loss and you are just doing this thing. Okay, so you do, I don't think so you have doubt in this. Then after what you are just doing this one, then after you want to see the prediction part. Okay, what the model has in prediction and what actuality, you want to match this thing. Okay, so you can do this thing also. What you have to do, prediction. Okay, prediction, what the model has been prediction, how you will do this one. So you will just write torch dot argmax. Okay, so argmax is basically, it will return you the index of that particular in which you have the highest probability. Suppose you are using, you have three neurons, okay, one, two, three, and in this particular three neurons, the first one you are getting the higher probability as compared to the two, so it will return as index as 0. Okay, so this is what torch.arguments it is doing, and you are just passing the output, that is the output that what you are just getting from that, and then you are just passing dimension as 1. That's same as it is if you have done in the pandas as x is equal to 1, so you are doing across the column. Here everything it in the vertical way, so you are just doing for the output layer. Okay, so this is what the prediction you have done. Then after you will append this thing into train accuracy, what you have just initialized here. So plus equal to, if that particle prediction equal, if your particle prediction equal to labels. What does it mean? Means if your particular prediction what the model has been predicted and that has been equal to labels, then you are just summing of this all thing. Okay, you are just summing of this, and then after you are just and from that particular you are just want that particular item, you don't want in the list form. Okay, so you are doing this one, so you are from this particular you are getting the accuracy. Okay, so it's like really basics for Python. It is, so no need to go in depth is what it is doing, dot sum dot item. Okay, so you have done this thing for this particular accuracy for the training part. This is the training you have done, but again you have the training accuracy and training loss, you want to append this thing. Okay, for that what you have to write here, you can go backward, so that for the every epoch you can just append. Okay, so what you can just write here, training accuracy, okay, dot append. How, what you will just write here, you will just write here what you have get the for this particular train loss. Okay, sorry, train accuracy. So train accuracy, after summing of, after running the every iteration, you will get some accuracy. Okay, so you are just writing this thing, and then after you are just dividing the length of total, you have the train set. You have already you have defined the train set, means if you have total 10 digit out of 10, you, if your model is predicting 8 as a good and rest 2 is not good, then you are just saying 80% is your training accuracy. That what you are just doing here also. Okay, train set. And similar you are just going for the training loss. Okay, you are just writing for the training loss, and that append, and then after you are just passing the train loss, but here you have to divide with the train loader. Okay, so why we are just dividing with the train loader, means you are just dividing everything in the batches, because after, see what you will be, what it will just model will give you the return, what will return, because you have 64 images in one batch, so model will calculate the 64 loss and they will divide by their 64 the batches. Okay, that's what, this way the loss it is going, they are just taking 64, then they are just take then after they are just calculating the loss, what you are getting the loss, then it will going to back propagation, then after it is updating the bits. Okay, so it's already has been taken 64, so no need to go for the trains, and just you have to write here train loader, length of train loader. Okay, clear. So you have done the training parts, is really clear. Then after, if you will go for the testing parts, again we will do for the testing part also here only. Okay, so in the testing means in during the validation part, you are not going to change the weight. Okay, you are not going to change the weight, you are not going to calculate the gradient. You want to see after every epoch what will be the accuracy by that. Okay, means what is giving the accuracy. If the model is trained, then on doing the first validation what is the accuracy, during the second validation what is the accuracy. Okay, so for that you are just saying eval mode, means you are now in not in the training mode, you are in the evolution mode. Okay, that means you are in the testing mode. Okay, eval mode. Okay, so for first of all what you are going to write here, again you will just initialize with the train loss something 0.0, you will initialize, and similar you have to initialize the train accuracy as 0.0. Okay, so now with after that you have to write for with toss dot no grade. What does it mean? Means you don't want any gradient for that. Okay, it's like toss dot no grade, no grade. What showing me like this, no need. Okay, so what does it mean, toss with toss dot no grade? Basically means you don't want any gradient for that. Okay, so for that you now you want to just loop through the same way, you will just write everything, but in the case you will not write the loss dot backward and optimizer dot step and optimizer dot zero grade, means you are not calculating any gradient, you are not updating the weights of this during this, you are just checking on the model, that's it. So sorry for that. For images comma labels, you are just going to write here, give me 1 second. Drinking water. Okay, so for images comma labels, you will write in the test loader. Okay, so what we have already defined, um, test loader, this one. Okay, and then after the similar way you have to write here output. Okay, so output equal to model, and then after you are just passing the images for that, and then after similar way you will just calculate the loss. Everything will be the same way. So loss, you will just write here the loss function. You already have the loss function, you are just passing basically output comma labels. You're just passing this output comma labels, and similar way you have to just you have to just set for this particular test loss. Okay, the test loss, what will be the test loss plus equal to a loss dot item. That's it. Okay, the what you have done the above, so no need to explain the again. Only in the difference between them is that you are not going to update anywhere. That's it. This is the main difference. Okay, the rest how you are just calculating the loss or prediction, it will be the same for that. Okay, so what you are just writing here, the same torch dot you are just going to torch dot argmax. Okay, argmax, and then after that what you are going to say from output, from that, then after that you are going to for the one dimension. So already this thing I have explained about the prediction means from the torch it will give you the index of that particular. Okay, so from that which particular neurons has been fired means which has the highest probability, that particular neuron will be fired. Okay, so you are already clear with this. Then after that what you are going to use, then after you are again you are just seeing the accuracy of this. Then after that you can just do the same as it is. You can just do plus equal to, if your prediction, if your what done your what the model has been predicted and what it is actual match with that particular what actual model has for that. Okay, then what you are going to do, you are just summing of that, and from that you want only the item. That's it. You are going to this. So that's it for this, and then after that what you are going to use, you have calculated the loss, you have the train accuracy, you have the test accuracy. Okay, so now you again you have to append this thing in this what you have already have defined, that is the testing loss and testing accuracy, so that you will able to visualize this thing. Okay, so this is what you are going to see, and then after that we will see this thing. So what we are going to write here, testing testing accuracy dot append. What we have done the similar way we have to write here, test accuracy divide by length of test set. Okay, test set, the similar way we have to write for this particular loss. Okay, testing loss dot append. Okay, you will just write here test loss, okay, divide by length of test loader. Okay, you have to write the test loader. Okay, so I think you are clear with this. Okay, you already append this thing. Now what you have to do, now you have to print this thing. Okay, so you want to print this after every epoch, you want to see what is the accuracy, what is the loss for that. So I'm just writing this thing as a placeholder. Then after you're just writing training accuracy, then after this is your placeholder, and you want only up to plus 2.2 f, means basically means the two floating value, up to two floating value you want. That's it. Okay, and then after again you are going for the testing accuracy, you want to see the testing accuracy for now only, how they are just decreasing, and you are just writing the two web. The similar way you have to write the training loss trainin loss, and then after again you have to write the up to two floating value you want this one, two floating value again you, and then after that again you are just writing testing loss. Okay, testing loss, and this is what you are going to write here, and then 0.2f. Okay, so this already have just done. Then after that you want to print this thing, that is forward, just do, and then after you want to go start with the epoch plus 1, because by default it will start with the 0, just mention epoch plus 1. And then after that what is the training accuracy, to training accuracy what was the train accuracy divide by length of train set. Already we have seen this thing, and similar way you have to do with the test accuracy divide by length of test set. Okay, test underscore set, and similar way we have to do for the loss also. Okay, so training loss is already we have defined train loss divide by length of train loader. Okay, train loader already I've seen why we are going to use the loader for that, and similar way we have to go for the test loss also. Okay, test loss divided by length of test loader. Okay, clear with that? So I don't think so you have doubt in this. It was really easy. So you have created this particular function. Either you can just check, if you will do any mistake we will see this time, no need for that. But the main focus was that you have created this particular training function. In that particular training you have done the both the training and validation both. Okay, you can just train a validation function you have just created. Okay, so this part you are going for the training part, and then after this part you are going for the testing part. Okay, the same after every epoch you are going to see this thing. So let's run this one. Okay, so hope so it will not give the error. Why during the first it is giving the error. So train accuracy is what is saying there. Training accuracy, what I have done. Oh, double. Okay, sorry for that. Okay, you have just it run. Now what you have to call, you have to call the model. Already you have this ANN model. First we will see the what is the accuracy of the ANN model. Okay, so for that you have to call this training function. You already have the model, that is the ANN model you are going to pass. You already have. Then after that a loss function and then optimizer. Okay, so loss function, optimizer. So what you are going to write here, loss function, you already have created the loss function, you already created the optimizer for that. Okay, and then after by default epoch is 10, no need to pass. If you are passing 5, you can just see, just run this thing, hope so it will give you the output. So for the total we have just used the 10 epoch. Okay, so for 10 epoch it will take some time to train the model, 10 epochs. So you are able to see you have get the training accuracy, testing accuracy, and then after training loss and basically the testing loss. Okay, so what we are going to see one thing, what you can just do this thing, you it will take some time for that training part. Even if you have done any mistake, what you can just do, you can just recheck this one. Okay, so what we have done, okay, so we have just trained this particular model. Okay, so we have just trained this particular model, we have just taking the for list above that. Then after that you are just looping through the all the epochs. Okay, so you are looping through the all the 10 epochs. Then after you are just initializing, so you are just initializing train loss and train accuracy. Okay, so what is the train loss is basically zero. You are just initializing what train loss and train accuracy. Then after you are in the training phase. Okay, then after you are just looping through for image comma labels in the train loader. Okay, you have the train loader, and then after you are just optimizing this particular gradient for that, and then you are passing these particular images to the model. Okay, then after you have the loss for that, you have loss dot function, means you have the output comma label. In that output comma labels you are just passing what the model has been predicted and what actual it is. Okay, and loss dot backward, you are just calculating the gradient for that, and optimizer step you are just updating the weights. You are just clear till now. Then after the train loss, we already have initialized this thing, train dot loss. In that you are just adding the loss dot item. Okay, and then after for the prediction, okay, you already have the prediction for that. The prediction equal to toss dot argmax. Okay, just passing the one for that. And then after train accuracy, you are just saying what will be the train accuracy for that. Train accuracy is equal to prediction equal to label, then dot sum dot atom you are going to use for that. Okay, so this is how you are just calculating. And then after training accuracy and training loss, you are just appending this basically for the, you want to visualize this thing. Okay, so you want to visualize, so after every epoch you will see, you will get some output. Okay, and you are just adding on that. So I don't think so you have doubt in this. And then after similar way you are going for the model evaluation, means you are just doing the testing phase. You want to see this thing. Okay, so you are again, you are just looping through with toss dot no grade, means you don't want to check the gradient for that. I am getting the everything as same accuracy, we will see for this, don't worry for that. It's like a many time like 90, those who are beginner, they will suffer this kind of problem. Again, what I have done, I will explain you, so this type of mistake you are not going to do again. So for that, what you are just writing again, you are just drawing with toss dot no grade. Okay, so with toss dot no grade is basically that you are just saying to that particular model that this is not for the gradient. You don't need any gradient because you are not updating any weights for that. Okay, again you are just looping through the test loader. Then after you are just passing this thing, the all the images, and then you are just calculating the loss for that, the similar way what we have done. Then again you are just passing the test loader as loss dot item. And then after from that you are just writing the prediction, and then for prediction toss dot argmax, you are just returning that one. Then again the test accuracy, what you are getting, prediction equal to label dot sum dot item. Okay, so from that, like you already know, test accuracy dot append you are just creating. And then after that testing accuracy dot append, you are just writing test accuracy by length of test loader. Basically you are doing the same as it is, what was the test accuracy divided by whole of the test set. Okay, that is the 10,000 you have in doing the testing for testing one. And then after you are just writing this particular epochs. Okay, the what is the train accuracy, you are going to see what is the test accuracy, what is basically your test loss and trace accuracy. Okay, what you can just do, restart and run all. Okay, so we will see this thing again. restart and run all. Okay, so we are going to train it, model it again, so it will, hope so it will not give you that type of error, or you already have the train set, test set, you already created this model. Okay, you have everything for now. Okay, so this, after that we have not used the softness for that. Yeah, no need for that. And even we can just see, you are just going for the ANN model first, so you can just see this type of things. Yes, we are going to use loss, as we are going to use this basically learning rate is 0.01, no problem for that. Yeah, and again what you are just going to write here, so what you can just create here, loss function, you can just mention here. Okay, so it may give it, now it will not give you that type of error. Okay, so only for the ANN model you are just passing. Okay, so what you can just do, restart and run all, you can just do. Okay, and now you are able to see now what will be the output for that. Okay, so you are just restarting this all everything, and you are just running all. So you can just see it will, it is running, it is importing the first. Okay, oh, it is done till now, it's done now. It's during the training phase. What will be the accuracy we are going to see? So yeah, hope so it will give you some output. Yeah, you are just seeing this one, training accuracy at 0.15, testing accuracy at 0.18, and you have the loss, you have the, and then this how the training accuracy and testing accuracy is increasing after every epoch. Okay, so what was the problem in that, you will just figure out this type of problem, it is done by the beginner. Okay, so the thing is that what I have just done the same thing, because I want to guide you this thing in the proper way, because whenever you are just writing this model, every time whenever you are just creating the object of the model, just create the first, so that you are just passing this model as a parameter. This stochastic gradient descent is the most important step. With the help of gradient descent you are able to change the weight, this is the most important things. Okay, with the help of gradient descent you are able to change the weight. Okay, during the back propagation. So this is a really important step you have to do, and in the model dot parameter you are just you have the weights of every parameter, and you are just changing the weights during the back propagation. And stochastic gradient descent, they are just calculating the gradient with the help of that, means w new equal to w old minus learning rate into gradient. What is the exact formula you are just saying? Okay, you are getting something. Okay, I have mentioned only the 10 epoch. Okay, so no for that you are getting the much low accuracy, but you can just increase your epochs as 20. If you are, if I'm just doing as 20 times, so it may give me a good accuracy for that. Okay, so again what you can just do, just copy this thing. Now you want to see for the CNN model you are going to use. Okay, for CNN model, what will be the output we are going to see, let's see. And just train this thing, and then after what will be the, see what is what you are going to see the output. So again you have just trained this thing for the ANN model, because you have just created the object for the first ANN. Now you are just training the similar way for the C convolution neural network. Okay, for the CNN model, I don't think so you have doubt in this part. So I'm just going from each and every step. If you understand this particular training thing, so this thing it works on the same for the ANN also, for the CN also. Those who are beginner, they will just think that ANN function of the training is different as compared to the CN. There is no, if you are, unless you are using any pretend model. Okay, so pretend model, that is resonant inception net, we are going to see this thing in more detail. Okay, so that are really different thing. Pretend model, even we will do with the help of PyTorch, we will do many project for that. Okay, in the next video we will see how to visualize this particular model. Okay, we have trained this particular model, we are seeing every time. And then also the second thing is that already I have said to you that a CNN convolution neural network will give you the higher accuracy as compared to the any ANN model. Why? Because because the convolution neural network only deal with the images, and this whole the images where the image object it is in that particular image, it will focus and at that part only. It will just reduce the what you have useless pixel. Okay, I can just think that you have one image, just think that you can just visualize you have one images, and in one images any person, it is inside of that images, so the side corner only the particular CNN will focus. Okay, and the rest it will be removed. The pixel is useless pixel, you want to concentrate where the person is, that's it. But in the ANN it is taking every pixel, it has the weights, and you are just feeding everything into a ANN model. Okay, so that's why it is giving the low accuracy as compared for the ANN model. But CNN will 110% it will give you higher accuracy as compared to the ANN model, only in the case of images and data you are just going to use. Okay, okay, So this was about the training period and how you are getting, and each and every step I have make you clear, even at the second for the second time, and what the why you are getting the same loss, same loss, this type of problem you are facing this thing. Okay, so that's why again I have showed you that thing, and again from that you are getting the ANN accuracy and AN loss. So in the next video we will do the visualizing part. Okay, so visualizing part is really more important thing. So you will see after every training accuracy and training loss, what you are just seeing things. Okay, so what we can just do, we will continue this thing in the next class and next video. So it will take some time to train the model. Okay, so in next video I will just show you how much accuracy I got in this particular video. Okay, that's all for this video. If you like our channel, please subscribe our channel. Thank you.